At NVIDIA's GTC 2025, the AI community was hit with a shockwave. Yann LeCun, one of the most respected minds in artificial intelligence, stood on stage and made a statement that sparked both excitement and controversy. "I'm not so interested in LLMs anymore." That one sentence quickly exploded across Twitter, igniting debates, hot takes, and endless speculation. After all, we're living in the age of LLMs. Large language models are everywhere. They're writing our emails, powering chatbots, coding apps, even passing medical exams. So when someone like LeCun, literally one of the founding fathers of modern deep learning, says he's moving on, the AI world listens. Let's be clear, this isn't just a hot take. LeCun is not a trend chaser or someone looking for headlines. He's a pioneer who has spent decades building the foundations of the AI systems we use today. So if he's signaling a shift, we better pay attention. What follows isn't just a critique of LLMs, it's a roadmap for what comes next. In this video, we're diving deep into LeCun's argument, his vision for future AI systems, and the radically different architecture he believes will be key to achieving artificial general intelligence, or AGI. And no, it's not based on token prediction, it's something much more human. At the heart of LeCun's critique is a fundamental question: can language models alone ever lead us to true intelligence? His answer emphatically is no. And to understand why, we have to explore the four pillars he says will define the next era of AI. The first is understanding the physical world. AI today is very good at understanding language, but that's not the same as understanding the world. You and I don't navigate life by guessing the next word in a sentence. We touch, see, move, and interact with real objects in a real space. But to LeCun, this is all superficial. It's like putting a calculator in the hands of someone who's never taken a math class and calling them a mathematician. He argues that real reasoning doesn't happen through predicting words. It happens in abstract mental space. This is where LeCun's vision gets profound. He introduces the concept of world models. These aren't just models trained on data. They are mental constructs, representations of how the world works that can be manipulated internally. Humans do this instinctively. When you imagine a cube rotating in space or picture a sequence of events, you're using your world model. You're not relying on words, you're using an internal, abstract map of reality. According to LeCun, this is where LLMs fall short, because they operate entirely in token space, discrete, finite symbols. They struggle to represent continuous, high-dimensional data like video, motion, and real-world cause and effect. Predicting pixels in a video is far more complex than predicting words in a sentence, and so far, even the best efforts to train video-based world models have largely failed. LeCun argues that the architecture of LLMs, based on transformer models predicting the next token, simply isn't suited for this kind of complex reasoning. What we need instead, he says, is an entirely new framework, and that's where his own work comes in. He calls it JEPA, short for Joint Embedding Predictive Architecture. The idea behind JEPA is that instead of working with tokens or raw pixels, the system builds internal abstract representations of the world. Representations it can then manipulate, reason over, and use to plan actions. Think of it like giving AI an internal whiteboard where it can sketch ideas, test them, imagine outcomes, and make decisions, not just regurgitate text. This internal reasoning space mirrors how humans think.
I'll tell you one thing which may surprise a few of you. I'm not so interested in LLMs anymore. Four things. How you get machines to understand the physical world, and Jensen talked about this this morning in his keynote. How do you get them to have persistent memory, which not too many people talk about. And then the last two are, how do you get them to reason and plan? And there is some effort, of course, to get LLMs to reason. But in my opinion, it's a very kind of simplistic way of viewing reasoning. I think there are probably kind of more better way of doing this. So I'm excited about things that a lot of people in this community, in the tech community, might get excited about 5 years from now. But right now it doesn't look so exciting because it's some obscure academic paper.
But if it's not an LLM that's reasoning about the physical world and having persistent memory and planning, what is it? What is the underlying model going to be?
When you imagine rotating a cube or visualize a route from your home to the grocery store, you're not thinking in words. You're reasoning in abstract space. Even animals like cats or birds do this when they plan jumps or flight paths. Language isn't required for intelligence, mental modeling is. LeCun further connects this to the psychological framework of System 1 and System 2 thinking. System 1 is fast, intuitive, automatic. It's what we use when we catch a ball or drive on a familiar road. System 2 is slow, deliberate, effortful. It kicks in when we solve a puzzle or make a difficult decision. Today's AI, especially LLMs, largely operates in System 1 mode. It reacts quickly and fluently, but lacks deep understanding. What LeCun is proposing with JEPA is an architecture that can eventually support System 2, a form of deliberate, goal-directed reasoning that uses a world model to plan actions. That's what we'll need for AGI. Now, here's the part that really turns heads. LeCun believes AGI will not come from LLMs at all, not as they exist today, and not even with the incremental improvements we're seeing. No matter how big the model or how much data it's trained on, if it's just predicting the next word, it's fundamentally limited. Real intelligence, he argues, will emerge from new architectures that model the world, not language. This is a big deal. It means that the billions being poured into scaling LLMs might not be bringing us any closer to AGI. It also means that the next AI breakthrough won't look like ChatGPT or Claude or Gemini. It will look like something else entirely. Something grounded in perception, memory, reasoning, and planning, not just text. So what does this mean for the future of AI development? For one, we may see a shift in where the smartest minds and biggest investments go. Instead of just scaling LLMs, the focus may move towards building better world models, more capable memory systems, and new forms of reasoning engines.
So a lot of people are working on world models, right? So what is a world model? A world model is, we all have world models in our mind. This is what allows us to kind of, manipulate thoughts, essentially. So, we have a model of the current world. You know that if I push on this bottle here from the top, it's probably going to flip, but if I push on it at the bottom, it's going to slide. And, if I press on it too hard, it might pop. So we have models of the physical world that we acquire in the first few months of life, and that's what allows us to deal with the real world. And it's much more difficult to deal with the real world than to deal with language. And so the type of architectures that I think we need for systems that really can deal with the real world is completely different from the ones that we deal with at the moment, right? LLMs predict tokens.
Right, but tokens could be anything. I mean, so our autonomous vehicle model uses tokens from the sensors, and it produces tokens that drive. And in some sense, it's reasoning about the physical world, at least where it's safe to drive and you won't run into poles. Why aren't tokens the right way to represent the physical world?
Tokens are discrete, okay? So when we talk about token, generally we talk about a finite set of possibilities. In a typical LLM, the number of possible tokens is on the order of 100,000 or something like that, right?
This could also mean more emphasis on robotics and sensory input, areas where AI interacts directly with the physical world, not just language. Companies like Meta, where LeCun leads AI research, are already moving in this direction. So are newer research labs and academic institutions that realize the current paradigm, while powerful, has limits. The future, according to LeCun, isn't about predicting the next word. It's about understanding what that word means in the context of the real world. And that's what makes this moment in AI history so fascinating. For years, we followed a straight line. More data, bigger models, better results. But now, one of the field's greatest minds is telling us it's time to change course. Not because the current path isn't working, but because it's not enough. Yann LeCun isn't abandoning LLMs because they're bad. He's moving on because we need more. We need systems that can think, plan, remember, and imagine. Systems that don't just sound smart, but are smart. And that next step, he says, lies in building world models that go far beyond anything we've seen so far. So if you're an AI developer, researcher, or even just someone fascinated by the future of intelligence, now is the time to start looking beyond LLMs. The frontier isn't in better chatbots, it's in better brains. And if you want to stay ahead of that curve, understand the next generation of AI before it hits the mainstream, make sure you're subscribed to WebSpark. We break down complex ideas into content that informs, inspires, and prepares you for what's next. Call to action. If you found this video insightful, don't just scroll past. Subscribe to WebSpark right now and tap the bell so you never miss a drop of AI innovation. For even deeper insights, strategies, and expert breakdowns, head over to Judy for Marketing, your go-to hub for cutting-edge AI content, industry updates, and marketing strategies powered by next-gen tech. The age of LLMs is still here, but the next evolution is on its way. Are you ready to move beyond tokens and into the future?